In this video, we're going to talk about the fundamentals of probability, and we're going to focus in on three types: theoretical, empirical, and subjective. So theoretical is the idea that we are basing it on things having an equally likely chance of occurring. So when I'm tossing like a quarter, a dime, and a nickel, there's an equally likely chance I'm going to get a heads or tails, right? 50-50 chance on those two outcomes when I toss the coin. So if we're using that logic, this is what we consider a theoretical probability, what we're doing here in example one. So we're going to start by drawing a tree diagram to look at the possible outcomes from doing this little scenario here. So the first thing I'm going to do is I have quarters. So I'm going to start with two options for quarters. So let's just kind of give myself a starting point here in the middle. Do my best to give myself space. And there's my two possibilities. I will have either heads or tails, and this is based on the quarter, which I'll write up here. Okay, then after I toss the quarter, I'm going to toss a dime. So I have two more possible outcomes, another chance of heads or tails. So that's for the dime. And then repeat for the nickel. But I also have to repeat that down here for the dime if I got tails. So it has a possibility of heads or tails again for the dime, based on either outcome I got from the quarter. Okay, now I will repeat for nickels. Oops. So I could get heads or tails, or heads or tails, or heads or tails, or heads or tails. Oops. And I'm going to go ahead and kind of put a dot to indicate the end point for all of those. Heads or tails here. Okay, and that was nickels. Here, I'll put it above since I ran out of space. Okay, so here are the possible outcomes then for the very first one. And I'm kind of following the top row here. So I'm saying, all right, so I'm doing, first one is heads, 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 which would be the first type of possible outcome. All three turn out to be heads. Then I would go heads, heads, tails. Heads, heads, tails. And then I would go here. I should erase that so you could see what I'm drawing when I'm doing it each time. Sorry. So the next one would be heads, tails, heads. And I think we get the idea now. So we're looking at each branch. I'm going to go ahead and erase that and listing the possible outcome for each branch. Okay, so the next one is heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So there's all the possible outcomes. And you can see that if I counted them off, there's 8 outcomes possible. All right. So part B says, can you think of a way to multiply to find these outcomes? And they call this the multiplication principle. And it's the idea that each coin offers itself 2 options, heads or tails. So when I look at the quarter, I have 2 options, and the dime, I have 2 options, and the nickel, I have 2 options, or 2 times 2 times 2, which comes out to 8 total options. So I know I did it right because I did get 8 outcomes possible. All right, but now with this information, we can kind of start asking more detailed questions, like what's the probability of getting 3 heads? Well, there's only one way of that happening out of the 8 possibilities, and that's the top one, right? This is the only way I'm going to get heads 3 times. So that's 1 out of 8. And you could leave it as a fraction, nothing wrong with that, unless they ask you to do a decimal. If you wanted to, you could. It's 0.125, just in case you were wondering, or if you want to write it as a percent, that's fine. But, you know, mom tends to ask you what form to put it in, so just kind of be mindful of that. Okay, now what is the probability of getting exactly one head? Okay, so that's a little bit different. That means then we're looking that we only have one head. And the first one that qualifies here is this. That has one head, two tails. This one works, tails, heads, tails. And this one works, one head, two tails. Okay, so that would be 3 out of 8, which is a perfectly acceptable answer. You want to put it as a decimal, it's 0.375. Now, the reason I'm going to go ahead and write the decimal, even though the fraction is okay, is I'm going to use that in the work below. I think it'll be a little bit nicer in decimal form down here. So what we're going to look at is what's called a theoretical probability model. And we're going to actually use this in the next section, which is why I feel like it might be nice to have it as a decimal. It could be fraction. I don't know why I'm being so specific. So what we're saying is, really, there are 4 options for how many heads we have when we look at our final 3 result. We could have 0. We could have exactly 1 head, 2 heads, or 3 heads. And the probability of getting 0 heads, that's only happens if you get all tails, right? And that's 1 out of 8, or 0.125. The probability of getting 1 head, well, we actually calculated that here in part D above. So that's 3 out of 8, or 0.375. The probability of getting 2 heads happens to also be, there's 3 ways to do that. You can kind of see it sitting here. There's 3 of them that have 2 heads, 1 tail. So again, 0.375. And to get all 3 heads, we calculated that in part C, that's 0.125. And we can use this table to kind of represent all the types of outcomes that we have here. So what's the probability of getting 1 or 2 heads? So the probability of getting 1 head is 0.375. And the probability of getting 2 heads is also 0.375. And I notice we're doing an OR probability. Now with OR probability, we have to be worried that there might be overlap. So when I look at that you might get 1 head or 2 heads, I hope you notice they have no overlap. Oops, I was going to do that in green. No overlap. And that matters because I don't have to worry about subtracting that overlap out. I can just add up the probability of getting 1 head and the probability of getting 2 heads, which comes out to 0.75, or 3/4 if you're doing fractions. So what's the probability of not getting 2 heads? Well, that basically means we'd be looking at all the other categories. So it'd be the probability of getting 0 heads, which is 125, probability of getting 1 head, which is 0.375, or the probability of 3 heads, which is 1.125 again. And that totals up to 0.625. But they use this kind of phrase here, complement. And that refers to certain types of ways of calculating, meaning it's like the opposite of what, we're looking at that's not in that category. So when they are asking for the probability of not getting 2 heads, that means we're basically excluding this category completely. We want everything but that category. So we're looking outside of that. That's what's called a complement in probability. Okay. What's the probability of getting fewer than 2 heads? Well, that means that they get 1 head or no heads. The first 2 categories, basically. So 0.125 and 0.375, which comes out to 0.5. Half of them. Makes sense. There's kind of symmetrical here. And what's the probability of getting at least 1 head? That would then qualify for basically being at least 1 head, means that anybody or the 1 head category would work, but so would 2 heads and so would 3. So all 3 of those categories work. So we'd add those 3 probabilities together, 0.375 plus 0.375 plus 0.125, which comes out to 0.875. So that's how we would find that probability. Now, we're going to look at the other 2 types of probabilities, empirical probability and subjective probability. Now, empirical basically means we're basing it on observations. We don't have this theory behind us any longer. So an example is 15% of parts sampled were defective. That's because when you're making something, you don't necessarily know what percent is going to be defective. So we'd have to actually gather a sample and see how many of them end up being defective. That's empirical. So it's based on data. Subjective probability is something we kind of do a lot ourselves based on intuition, experience, or feeling. What's the chance that you're going to go to a party on Friday? You know what the odds are, if it's going to be pretty good or not. Maybe you love going to parties and the chance that you don't go is very small. All right. Or maybe you know somebody who tends to run late. So you know the odds of them being late. That's kind of subjective probability. It's based on data, but it's not recorded data that we're necessarily really keeping track of. Okay, so we're going to look at relationship between odds and probability, because odds do kind of play into probability theory. And looking at the idea of odds, like a team is given odds of winning of 4 to 7. What that means in the phrase, the way they worded that, odds of winning matters. So that means that the first thing they told us is the chance that they're going to win. And the second thing that they told us is the chance that they're going to not win or lose. I'm going to zoom in a bit here. So what is the chance that they're going to win? That's the probability that they're going to win. Okay, but that isn't 4 out of 7. It means that there's 4, the chance for 4 winning 4 or losing 7. So when we do odds, we actually take and total those. So it's 4 plus 7 or 11 total. So the odds are technically out of the total of those 2. So the probability of winning then is 4 out of 11. And I'll just leave that as a fraction. That would mean that the probability of losing is 7 out of 11. Then there's another phrase you should know, and they often say odds on instead of odds against, but that's what it means. Odds on means it's the odds against something winning. So if it's for winning, they'll usually say that. But if it's against, they'll say odds on, which is typical. So like in this example here, at a horse race, the odds on My Little Pony are given 8 to 1. So odds on means odds against. So the first one here is that they're going to lose versus win. And according when I'm talking about the actual probability. So what is the probability of My Little Pony winning and losing? So winning is 1 out of 9. Losing is 8 out of 9. Now, the 8 to 1 odds means that for every $1 you bet, you get $8 if you win. That's how odds kind of work. It's telling you what your winnings will be. So if you bet $10 that My Little Pony is going to win, that means you're going to expect $80 in winnings if you bet 10. And I'll do combining probabilities in another video.